Thank you very much for the warm introduction, Eric. It's great to be here in Red Bank. So, we all remember a nasty lady that came to our shores, Sandy, in 2012. Eric mentions my shore house. My shore house was flooded in 4 100-year floods since I bought it. This was the second worst. This was 1993 in December northeaster. And during Sandy, it was 1.5 feet higher. And I'm a geologist. I look at sea level changes, one of my primary topics, both here in New Jersey and elsewhere. Most of my field work is in New Jersey. And this is a New Jersey's view of the lady in the harbor with an ice-free world. It's anatomically correct that if you melted all the ice sheets, this is how much sea level would rise. And sea level has been this high in the past. It's been much lower in the past. So before we get to that, there's some audience perspiration required. I'm going to put up 4 questions, and I want you have to vote for one of them. So 4 questions is, I'll start out with the first one. Please raise your hands. I was going to do this by secret ballot. I figured let's do it this way. I did it by secret ballot with the architects on Wednesday. It was quite interesting. It has been proven that human activities are causing global warming by releasing CO2. Okay, thank you very much. More than half. It is very likely that human activities are causing global warming by releasing CO2. Good. Third, global warming is due to a natural cycle and not due to humans. 0. And global warming is the greatest hoax ever perpetrated on the American people. So we have no senators here? Senator James Inhofe. So what is CO2? What is CO2? Carbon dioxide. Where does it come from? You're doing it right now, right? I drove here, I contributed by burning fossil fuels, cleared some of my yard, that contributed, okay? Then I planted something again, it goes the other way. How much CO2 is in the atmosphere? 400 ppm. We'll come to the exact number in just a minute, but yes, it's going up about 2 ppm per year, parts per million. But isn't it a trace gas? Come to that. And where does it go? The ocean takes up about half. Organic matter, so we have someone who understands. So we answer most of these questions, but here's one real important point. It's 400 ppm today, and it was 280 ppm in 1850. Now CO2 is not bad. Without CO2 in the atmosphere, the surface temperature today averages about 15 degrees Celsius. Okay? Actually, today it's 15.8, so we have warmed the planet. If we had no greenhouse gases in the atmosphere, no carbon dioxide, the surface temperature of the Earth would be minus 18 degrees Celsius. We'll release 10 gigatons, 10 billion tons in 2014. And as we said, the CO2 is going up to 2 ppm per year. So combustion of fossil fuels emits carbon dioxide in the atmosphere as the land use changes. Roughly half of it remains in the atmosphere and half goes into the oceans. Increasing CO2 is warming the Earth. Global surface temperatures increased by 1 degree Celsius from 1880 to 2014. CO2 isn't the only effect on the atmosphere and temperature, okay? There are other causes of temperature change, which include solar variability, volcanoes, and sulfate emissions. So greenhouse gas, this is going to put the 3 basic, we met with Governor Christie, Tony Broccoli and I. And this is right, I was running for the president the last time, and he made the announcement that he wasn't sure he believed in climate change. I don't believe in climate change. I don't believe in evolution. I don't believe in giraffes. There's no belief needed. Facts are stubborn things, as John Adams said. So he went in to see the governor at his request, and Tony Broccoli from Rutgers explained it very nicely. There's 3 basic lines of evidence. Let's go darn models! Watch them all! Well, the very first line of evidence comes from basic physics. CO2 increases the trapping of heat. This is a CO2 molecule. And as Rear Admiral David Titley, former oceanographer of the Navy, said on Capitol Hill, when it comes to belief in global warming, I attend a church of the radiated balance equation, which basically means the science is what determines energy coming in is absorbed by this molecule and re-radiated back to the surface. We will double CO2 in this century. It seems very likely. And by the way, the answer to that question was, we haven't proven human attribution of climate change, but it's very likely. And as a scientist, that means it's over 90%, perhaps, I think it's 95% now, sir. Well, what I'm typically trying to say here is that if we double CO2, temperatures must rise, okay? There's also observations. We see increased CO2 in the atmosphere, temperature has increased, sea levels have risen, Arctic's lost sea ice, melting mountain glaciers, melting the massive ice sheets. Who here is a gardener? Other than this year, the gardening season is getting longer and longer. This year is an interesting anomaly. We're going to get more floods and droughts and more reduction in snow cover. The third line of evidence is modeling. So here's where it comes to, what do you believe? So the IPCC, Intergovernmental Panel on Climate Change, and other scientists have this concept of climate sensitivity. How much will temperature change if you double CO2? And so the best answer is about 3 degrees Celsius. And that's what the climate models tell us. But it could be anywhere, and climate models tell us, from 1.5 degrees to 4.5. 4.5 is a great deal of warming. 1.5, we've seen almost 1.5 degrees of warming. So that's actually the central part of the problem. So this is CO2, as originally measured on the Big Island of Hawaii, in Mauna Loa, starting with Keeling. They call it Keeling curve. And it's showing CO2 is rising, and and this starts in 1958 at about 310 ppm. And now in 2014, it's 401.3 at the peak in 2014. It changes annually, seasonally rather. In the winter it goes up, in the spring, northern hemisphere, spring and summer it goes down as the Earth breathes. This CO2 rise is not natural. We know from little bubbles trapped in ice cores in Greenland and Antarctica that during the Common Era, at least, CO2 was about 280 ppm until about the late 19th century going into the 20th century. The CO2 is associated with a warming. So this is one of 2 temperature records going from late 1800s to 2008 in this case. So one of my alumni, sandbagging on this at a cocktail party, goes, well, Ken, CO2's been going up, right? I go, yes, it was since the Industrial Revolution, 1850, 1880, somewhere in that range. He goes, what happened to temperatures between 1940 and 1970? Well, they didn't go up. And Michael Crichton's book, A State of Fear, it's all a plot. And he says it's falling. Well, you read the data yourself. You think it's falling or rising. But the point is, it was that one Tony Broccoli I showed you the picture. There's one model seed showed that the main reason for this is suppression of global warming by the emissions of sulfate aerosols. So CO2 warms like a blanket, just like a blanket. That's how the CO2 greenhouse effect works. But sulfate reduction works like a window shade. It reflects back the radiation. So when we began to clean up the atmosphere, passing the Clean Air Act right about this time, anthropogenically induced greenhouse warming started taking over. So what's climate, guys?
Complicated.
So, what's the coldest day in New Jersey? Depends on the season. Somewhere around January 25th, give or take a week, we'll reach the coldest point. On a 30-year average, I think that's the number. But the coldest day could be February 1, or it could be December 1. That's weather. Climate is a 30-year average. And that's what this shows. This shows temperature for 30 years, and it shows 7 or 8-year running averages through it. And they're all over the place. So when people show you a record that's not 30 years, they're cherry picking. This is a poster. It appears in several places, and it shows the temperature record. The data are correct. Okay? It shows that there is no warming. 1997 to 2012, they're plotting monthly averages, makes it look like it's a nice representation. These are the data. I'm a scientist. I like data. Okay? And so this is from the Hadley crew compilation in the Met Office of Great Britain. And it cools a little bit in here because of volcanoes, Krakatoa and others. Natural warming here, mostly natural. Leveling off here from global dimming, and this is the last 30 years. So let's blow that up. So like that old football commercial,
you are attempting
makes the call. Okay. There's the 30-year average. Okay. I superimpose that 30-year average on the last 13, 15-year range. And this is what basically is shown in that poster. It's something I'm showing you annually. So if climate's 30-year average, is climate cooling or leveling off?
No.
I don't think so. So a conclusion for climate is we will certainly going to double CO2 in the atmosphere unless we do some dramatic things, and the temperatures are going to rise. If we do dramatic things, it won't rise as much. We can see some of the effects. So this is the Arctic sea ice minimum in averaging on a climate period here, about 30 years. This was the 2007, the minimum occurs in mid-September. The Northwest Passage opened for the first time. As I said, I like data. So one of the questions from the architects I had, isn't the ice in the Arctic coming back? Well, you make the call. It's decreasing, and if you project in this, the model said we'll have an ice-free Arctic by 2050. In 2009, all heck broke loose. And we're staying down at this lower baseline. That was last year's. Climate patterns. So, are storms going to increase in a warmer planet?
Yes.
We don't know. We know. Will tropical, so Dick Lindzen, a famous atmospheric scientist, a known climate skeptic in Wall Street Journal, basically said that storms were not going to increase. Right down the hall from him, Kerry, dangerous one in my brain, predicts that storm intensities, tropical storms anyway, will intensify due to warmer water. This is, of course, is Sandy. One of the things about Sandy is it took a hard left turn that no one had seen before, but it was predicted very well by the European models and then the American models a couple weeks out. And that may be in part because the Arctic is warmer. We can talk about that later. A quick summary of the likely impacts before I get to sea level rise, which is the last one on this list. Temperature increase, which increases disease transmissions and heat waves. New York gets about less than 100-degree day on average per year. We're going to see a half dozen of those. Arctic sea ice loss, crops, longer growing seasons, but you'll have more floods and droughts, increase in disease. Put this slide together in part for Rutgers Medical School, where I gave this talk 2 weeks ago. And of course, there is an increase in dengue fever, or dengue if you prefer, has reappeared in the United States as temperatures have risen. And then sea level rise. So the title I'd given originally was this title, A Geological Perspective on Sea Level Rise and Its Impacts. And we had a paper in 2013. So, of course, there's the Manahawkin Inlet that formed during Sandy. I'm from Medford, so we used to go to Long Beach Island, still do. My house is across from Long Beach Island, so this is the front page of the Philadelphia Inquirer. So sea level is like politics. It's all local. This is a picture I took of Ship Bottom, New Jersey, 27th Street here, Ship Bottom, here's Long Beach Island, if you don't know. There's Barney, Old Barney, Little Leg Inlet. And you can see this right after beach nourishment. Looks beautiful. This is right after Sandy. My friend's house is here. We projected, but by the year 2050, sea level in New Jersey will be about 1.5 feet higher, and by 2100, 3 feet higher. So Rutgers has a visualizing tool we can at least do to show you what a 1 foot sea level rise will do in 2040. Okay, so my grandkids will be able to go down to LBI, have to fight back. But by 2100, with a 3 foot sea level rise, we're facing a fundamentally different New Jersey shore. So are you. The highlands here, underwater. This area here, underwater. Sandy Hook, I'm surprised it didn't show. Of course, there's going to be a breakthrough. It's going to be impossible to maintain it there. And we can see this general area around here, the bay is flooding in. So Sandy was an important storm that brought a major storm surge of about 13.9 feet at the Battery in New York. You can say, well, what about other storms? Well, Hurricane Donna was the previous largest storm to hit the New York area. This is in 1960. This gentleman's going out to get some donuts in the storm. And so we can put recent storms and kind of answer empirically whether or not storm intensities have increased. So this is the flooding, and this is relative to, it doesn't matter what it is. We've heard about storm surges. When a storm comes through, it's a transient sea level rise caused by low barometric pressure and the winds piling up the water. And that gets added on to astronomical tide. Okay, so tides, especially when Sandy hit, it was particularly devastating here at 13.9 feet because it came at spring tide, which is astronomically high tide. But you can see there's a number of storms that are virtually 100-year storms. Now, when it's a 100-year storm, it doesn't mean this occurs definitely once in 100 years. It means in any given year, there's one chance in 100 that that will flood to that level. So you can see, as I said, my shore houses have 4 100-year storms, okay, since I bought it. The Northeaster Halloween, 92, 93, the Great December Northeaster, 2005, and Sandy. You can see the trend on here, this green line, this pink line, this blue line, where are they going? They're going up. That's because sea level's going up. So that gets added on. So if Sandy had hit in 1912 versus 2012, 65,000 New Jerseyans and 75,000 New Yorkers would not have been flooding. That is a result of a foot to a foot and a half rise in this region in that 100 years. So right before it was Irene, this previous year, so this prompted Governor Cuomo to make a really pithy statement. Climate change, that's controversial, right? He goes, let's not talk about climate change. Let's talk about extreme weather events. He goes, there's only so long you can say this is a once-in-a-lifetime occurrence and it's not going to happen again. Okay, 2 100-year storms. So with sea level rise, it's local, but it's one of the important controls is global. So global sea level rise is caused by warming temperatures, the tea kettle effect. I fill the tea kettle up and fill it all the way to the top, go to the stove and turn it on, and my wife's screaming, it's overflowing, because it's expanded. Also melting ice sheets, both mountain glaciers, like the Glacial National Park, and ice sheets. I should add, by the end, mid-century, the Glacier and Glacial National Park will be gone. But there's also, we have a sinking feeling around here. Well, the crust is being depressed. It's very sad. We call it subsidence. Okay, subsidence are sinking. Now, some places are going up, Alaska, Sweden, okay? This is something we call glacial isostatic adjustment, I'll explain. But there's also oceanographic effects. So the Gulf Stream, which is actually called the North Atlantic Current off here, offshore, when it decreases in its strength, can change sea level here and raise sea level here by about 10 to 20 centimeters. And then we have the local effects. Compaction due to natural processes and mining of groundwater. We'll come to that in a minute. So this is what North America looked like 20,000 years ago. There was an ice sheet that came down to Woodbridge Center Mall and the Scotch Plains. That melted away. 20,000 years ago, sea level was 120 meters, that's 390 feet lower than present, and it rose in 2 steps, where sea level was rising at 16 feet a century, slowing down a little bit here during what's called the Younger Dryas cooling, and then taking off again, and then slowing over the past 10,000 years. And so that brings up the question, is sea level rise part of a natural cycle? I'm actually quite surprised, I guess a fairly informed audience, that more than 1/3 of people, and not even taking party or denialist type people, think that the natural cycles are what's controlling sea level. In the temperature record, there are natural cycles, and you saw other effects. But from a sea level perspective, we can say the sea level during the Common Era was relatively flat. So there are actually Roman, basically fish tanks that vent through to the Mediterranean, and they're at the same level as they were 2,000 years ago. Sea level started to increase rapidly in the 20th century. Okay. So if we can answer the question, is it part of a natural cycle? Certainly not. So in the 20th century, there's new data here, is why this is all stricken out. Carlin Hay from Harvard and Bob Kopp from Rutgers, postdoc Bob Kopp and Cherry Mitrovic at Harvard, published a new paper. The sea level rise in the 20th century, we thought it was about 1.7 millimeters per year, which would be about 7 inches for the century. But it's actually a bit less, as their data show. Satellite data come online, which allow us, tide gauges are nasty critters, because some places are going up faster than the average. There's New York going up faster than average. Some places are sinking, so you have to take all that into account. With satellite data, we can measure the rise precisely. And this is showing you that over the past 30 years or so, 25 actually, I think, that we have a rise of about 3.2 millimeters per year. Can't do arithmetic. 1992 to 2015. So why is this? Again, because of thermal expansion and melting of glaciers and ice caps. I mentioned the Arctic, so here's a question for the audience. I mentioned the melting of the Arctic sea ice, okay? Does that change sea level?
Yeah.
Why not? It's already floating. Take a glass of water, put ice in it, mark the level, let the ice melt. Does the level in the water change in the ice?
Yeah.
Does not? Not measurably. Go do the experiment at home. Not measurably. Okay. Sorry?
But you're assuming the ice cube and the water is floating already.
Yeah, you have to have the ice cubes floating. If you, okay, so let's do it this way.
No, that's not what I was getting at.
Go ahead.
That the ice cube and the liquid it's floating in are the same composition.
Right. We're assuming they're both basically
Fresh water floating in seawater.
freshwater floating and seawater will change sea levels, but not measurably. It's really small, less than millimeter scales. Okay. But if you take that glass and fill it with ice to the top, right? Okay, just fill it so it's overflowing. Just mounting it up and let it melt. Okay, then you will have it coming out, and that's what's happening in melting mountain glaciers. So whether or not from the snows of Kilimanjaro here in Africa, through the Alps of Switzerland to the Alps of New Zealand, the length of the mountain glaciers are decreasing rapidly. Now, mountain glaciers are an important part of sea level rise, the melting of those. But if you melted them all, you would only get about 40 to 60 centimeters of rise. If you melted Greenland, this is a classic, I usually play this clip, or used to play a clip from Inconvenient Truth. If Greenland broke up and melted, this is what would happen. And he actually illustrated a 5-meter rise. Well, Greenland's about 7. Or West Antarctica broke up and melted. You'd also get about 5, maybe a bit less than West Antarctica. But if East Antarctica melted, we'd get 52 meters. Now, you don't have to worry about a 52-meter rise in this century, next century. Captain Picard wouldn't have to worry about it. But we are melting Greenland. This is surface melting in red, and we are melting East Antarctica. And they are contributing now to sea level rise. So, this is the melting in Greenland. This is the mass loss in Greenland going back to 1993, the satellite era. And Greenland is losing now about 370 gigatons per year. Now this is the number of gigatons per year of loss, and this is years. So a straight line on this plot of gigatons per year is an acceleration. So if you fit a line through this, you can predict what sea level rise is going to be. So a couple times after we met with the governor, one of the blogs was, he can't do arithmetic. Sea level's rising 3 millimeters per year. So in 100 years, that's only going to be 30 centimeters. About a foot. Okay. But not if it's accelerating. Niels Bohr, or possibly also Mark Twain, had a great quote. We're trying to predict the future here, right? Prediction is very difficult. especially if it involves the future. Take the lower limit is that 30 centimeters, right, of rise in 100 years. We know it's accelerating, so if we apply that acceleration, what we computed was 70 centimeters of global rise. And that's similar to what previous year the National Research Council had predicted, about 80 centimeters rise. They used other data sets that were a little bit older on how much mass was being lost. But here's the question, and I'd like to pose this question. Is sea level rise by 2100 rather, going to be 50 centimeters, 80 centimeters, or 140 centimeters? What's the answer to that question?
Oh, no.
Yes.
Yes.
And that's all we can say. So this is the global rise in sea level. You can see here at New York City, sea level is rising in the 20th century at about 3 millimeters per year. Atlantic City is seeing about 4 millimeters per year. So in the 20th century, you've got a foot at New York and 16 inches at Atlantic City. So this is due to the seesaw effect. Very heavy weight of 4 kilometers of ice in Canada melted away, and that's going to go up. When that goes up, what happens to us? We go down. And that blue means we're sinking or subsiding. So here's a plot, and it's a little complicated, but I'm going to try and use colors to make it. So there's New York City, there's Philadelphia, there's Baltimore, there's Washington. They all sit on bedrock. In fact, this is the fall line for the Great Falls of the Potomac. New York City sits on the Manhattan Schist. And all the tide gauges in the fall line record the same value, or about 12 inches a century. This is due to this seesaw effect that we call glacial isostatic adjustment. If we go to Atlantic City, it's higher, it's about 16 inches. If we go to Norfolk, it's about 18 inches. And Norfolk is a sea level hotspot. We know from our data that Atlantic City and Norfolk are sinking faster because of removal of groundwater. So this is, again, all sea level is local. We have the global effects, we have the regional effects, which what we see in Philadelphia is the same as we see in New York, the same as we see in Baltimore. We also have local effects due to compaction. So I put this slide in for you as a little, just to show you something local. So we drive up here to Sandy Hook. We drilled a transect of 3 holes last year at the South Maintenance Yard, Salt Shed, and North Maintenance Yard, which is right next to the tide gauge. Why do we do that? Why does Sandy Hook have as much sinking as Atlantic City? There's not much groundwater being withdrawn at Gateway National Park. You can sit out here and look across and see the tide gauge at the battery. Why is this region, this little area sinking? So we drill to find that out. We're happy students. We bring them out in the field. We drill. Okay. By the way, there's no oil exploration, as we said. Anything involved. We drill to get core samples. These are core samples. This goes down to about 300 feet at Sandy Hook North Maintenance Yard. And all the stuff in brown is muds. And those muds are naturally occurring. They're deposited during the deglaciation, the last major glaciation, and they're compacting. And that's why Sandy Hook has that sinking feeling. I mentioned the effect of the current we call the Gulf Stream. It's called the Gulf Stream here. Leaves the coast here is called the North Atlantic Current. There's a small 1 meter hill in the ocean. So for Bermuda, it's about a foot higher sea level relative to the center of the Earth. And that's relative to the East Coast. And that's because the current itself flows. If you relax that current, sea level rises. So we put all these effects together because, again, what you care about is what's happening locally, what's happening down on the beaches. So for the Jersey Shore, our projections are, by the year 2100, the best projection is that we're going to get about 3.5 feet at Atlantic City. At bedrock locations like New York City, Philadelphia, Baltimore, Washington, it's more like 3.1 feet. There's New York, again, about 3.1 feet. Now the question is that going to be 2 feet or is it going to be 4.5 feet? The answer to that question is yes. Worst case scenario, so here's actually a good ethical question for you. Jim Hansen of Goddard Institute of Space Studies, now retired from that, was one of the leading climatologists who warned us of the effects of global warming in 1985. And really, it went back into the 70s. Jim had a picture on the cover of New Scientist in 2007. It had a picture of Florida underwater with a question mark, 2107. Okay, 100 years. And it was very much like illustrated in An Inconvenient Truth. This is what would happen to New York. Okay. Vice President Gore gave no timeline in that movie. He was beaten up by a lot of people. From the Queen's bench, Judge Burton ruled that An Inconvenient Truth could only be shown in England to school children if the 9 deadly sins of the movie were revealed. And the most cardinal of those deadly sins were the so-called exaggerations about sea level. But Hansen put a timeline. Physically, it's impossible, virtually impossible, knowing anything we know about physics. We can't say it's actually, we say, is it proven that humans? It's very difficult for scientists to prove things, okay? I can't disprove for 100% that Hansen is wrong. But he knows it's an exaggeration. He's doing it to get an effect. I gave this talk at a meeting in that same year. We were running on sea level change. And one of my former, he was still a colleague, but he had spent a sabbatical year with me, Bob Carter from Australia. And Bob is now the lead author of the NIPCC. Not the Intergovernmental Panel on Climate Change. So this is the biggest bunch of skeptics. It includes the same people who read the book Merchant of Doubt, go see the movie Merchant of Doubt. Okay, it's that same group of people. And I saw Bob showing 5 years of temperature data and showing it, gosh, there's cooling. And that's when I said, Bob, why are you saying things that you know are not correct? Because people like Hansen are saying things that are not correct. My point on this is there's spin on both sides. We're not all going to hell in a handbasket, folks. If it's 3 degrees, we can adapt. There's going to be consequences, okay? We really do need to move to reduce dependence on oil and gas. So again, there's a petition at Rutgers about this right now, that we should divest from oil and gas companies. I'm quite conflicted in this. My son works for Chevron. I'm a geologist. 7 of my other students work for Chevron. I heat my home. I don't use wood. In fact, I wouldn't want to use wood because it would pollute the air, even though it's renewable. So we have to make a transition. This is, again, the ethical question that comes from this, and sea level change is part of that. Let's take a couple minutes, and I'll just show you some of the effects. So this is LBI. There's the boulevard. I used to come down here and park my car in Holgate and walk out the beach this way. Okay, by the time my son is now 30, so it's been 20 years ago, he came, it was about here, and this is about 10 years ago, it's already moved back. Sea level rise is not a bad thing for beaches until you build a house on it. The beaches don't care. They're just going to migrate landward. It's when we have to stop that migration. So we can fight back. Controversies perhaps about beach nourishment, absolutely essential if you want beaches. There's no way they can be maintained with these higher and increasing rates of sea level rise. So this is what 2100 will look like at Cape May Point in blue. Okay. So we fight back with beach nourishment. So this is Seabright. Before beach nourishment and after beach nourishment. I think this is a 1996 project. So here's again, I do teach ethics in my class. My class is called Sea Change, the rise and fall of sea level on the Jersey Shore. Okay? And one of the towns I like to pick on is, of course, Deal. Deal's refused beach nourishment. Why does Deal refuse beach nourishment? Because they have to grant access to the beach, and they refuse to. Love Ladies, of course, there's a famous case in Love Ladies, Harvey Cedars, actually, refused beach nourishment initially also. Okay. They were nourished in 2010, And as a result, when Sandy hit, there was minimum damage leveling. I showed you down in the mid part of the island. It was nourished in 2008. There was some damage. But in Beach Haven, and particularly Holgate, where there were 25 holdouts for signing access to the beach, the place was trashed. Now, I did find out my former student's mother, who lived in the trailer park in Holgate, they weren't going to be rebuilding. She has gone back, they did rebuild. But again, one side of this issue is this welfare or buyouts for millionaires. But the other issue is really, what about the guy with the little bungalow on the bayside who was flooded out because the people that owned the big house at the end of the street refused to have their view blocked? So I didn't put slides into this, but you know the story of the case, I think you've heard. It ended up in New Jersey court, Coran versus Harvey Cedars. Villis and Harvey Coran sued the town of Harvey Cedars for loss of view. Their house, right on the ocean, had a first floor view. After you built a 22-foot dune in front of the house, they lost a view. So, did they really lose something? Yes. You can look, you can do the estimates economically. They lost $365,000 in their house. Okay. Of course, when Sandy hit, their house was spared. So first in lower court and then in appellate court, it was held up that the $365,000 award was going to be made. It hit the New Jersey Supreme Court, and they did a QB5 on the issue. They basically didn't fully vacate it, but they awarded the Korans $1. And the reason why is they lost something, but it was nearly what they gained was the safety of their house. So QB5 was actually a great ethical movie about a court case on the Holocaust. Beginning to wrap up here. So this takes a minute to get your head around. This is New York, Atlantic City, rather. This is the 100-year flood mark. So that northeaster that I showed you in December comes here, and that's my house during that northeaster. At Atlantic City, Superstorm Sandy just equaled that. At my house, it went 18 inches above, and of course, at the Battery, it went 4 feet above the 100-year flood mark. So this is my house during Sandy. Okay. This is a tide gauge, and all it says is Sandy got about 18 inches above 100-year flood mark. But if you remember, there's a little northeaster the week after Sandy. The flooding power of that northeaster would reach this level, which is about 7 feet, okay, above mean level water. Now, that's the reference between a 100-year storm and a typical storm. Let's raise sea level by 1.5 feet. Now that little storm has a flooding power of a 10-year storm. And if you go to 100 years into the future with our projections of 3.5 feet, that little storm will be more powerful than a 100-year storm today. That illustrates how sea level affects basically the flooding. Those are just the numbers. So I'll put conclusions here. Global warming is real. We've seen about a degree warming, and again, is it 0.8 of a degree? Is it 1.2 degrees? There's errors. The answer is yes. Of which about 4 degrees is natural. Anthropogenic CO2 is very likely a primary driver of the warming, especially since 1975. So here's another great story. I like all stories. Climate skeptics. You scientists can't get it right. 1975, you said the new ice age is coming. In fact, I have slides showing the cover and all. I gloriously show that because I can tell the story. In 1975, guys, office was next to mine in Columbia. Jim Hayes, famous paleoclimatologist. George Kukla, whose office was also next to mine, went and stood in front of the Empire State Building, World Trade Center hadn't been built yet, and announced that it seemed likely that we would be entering a glacial period. If you remember that temperature, things were pretty cool for about 30 years. But the predictions from paleoclimatology is that minor variations in the Earth's orbit, okay, our tilt and our recession control the ice ages. Carbon dioxide does it. Carbon dioxide is responsible for climate change on geological scales, but the ice ages are mostly controlled by this Milankovitch pacemaker. And the pacemaker predicts that we would be entering a new ice age if it hadn't been for human release of CO2. The same year, Wally Broker, who was the big kahuna at Lamont Doherty Earth Observatory in Columbia, which is where I was, wrote a paper saying he was predicting that we would start overcoming the the cooling effect of global dimming and have a warming by 2100, which so far his predictions have been bang on. So warming and sea level rise are not caused by a natural cycle. We will double CO2 in this century and the temperatures will rise. Some more take-home points. Sea level rise appears to be accelerating. By 2100, global sea level rise will likely be more than 2.5 feet higher. Storm surge is adding to the sea level rise. A 5 to 10 year storm in 2100 will have the same effect as a 100-year storm now. Okay, I didn't talk about FEMA. This is real government needs, right? FEMA firms which are used, FEMA NOAA, which are used to make a firm. So, FEMA, Federal Emergency Management Association, is informed by NOAA, the National Oceanographic and Atmospheric Administration, and they set what's called the ABFEs now, the Advisory Basal Flood Elevations, which are then used to develop the firms, which is the flood insurance rate maps. So the governor made a quote that, I think the new ABFEs include sea level rise. He thought wrong. They do not. So those maps which would determine what your flood levels are do not include sea level rise. For both regional and global effects, adding on to sea level rise, we should plan for 1.5 feet by 2050, greater than 3 feet by 2100. And I can say unequivocally, I think by 2100 we'll be facing a fundamentally different Jersey Shore. So we were hesitant to make firm recommendations to policymakers, but we have. So for my son, if he buys my shore house, he should plan for an additional 1.5 feet, because he's going to have a house in 2040, 2050, right? And it's going to be 1.5 feet higher. So for zoning for low impact structures to target at least 1.5 feet. For municipal planning for structures with lifespans beyond 40 to 50 years, transportation, water, wastewater, energy, communications, you should use a higher figure. How much higher? Depends on your engineering. One of the reasons we were without power for Sandy for so long, especially at the shore, is a lot of the substations were placed there at the time of Thomas Alva Edison, when sea level was 1 to 1.5 feet lower. We should think going forward. So for purposes of planning infrastructure projects with significant public investments with lifespans from 2050 to 2100, it is prudent to employ higher scenarios. Just, if you're interested, I'll go over this slide later to give you actual numbers and examples of what we should do. We recommended to the governor that they should make 1.5 foot above what they currently have. Okay. So the last slide, and I would put this in and I hope it works. I have to use it many times. I wasn't going to use it for this talk, but I have a story. So, climate skeptics had a symposium at the Geological Society of America a number of years ago. And geologists can be pretty skeptical a lot. Looking back at ancient climates, they can be really skeptical. So I submitted an abstract and gave a paper and gave a talk. And it was unusual. Usually when you give a talk at GSA, there's like 30 people in the room. Well, this room held 500 people. And there were 500 people in there. And a couple of the climate skeptics stood up and gave talks, which were putting up pictures of Senator Inhofe, saying the scientists are just saying this because of money. These are scientists. So it got really raucous. Half the room was like jumping up and saying, "You should write a book exposing this climate madness." Dole Rudman stood up and said, "I wrote a book on climate, and I'm a skeptic." He goes, "But I got to tell you, at the end of the day, I think the IPCC got it pretty much right." So they're yelling and screaming. So I walk out of there at the end. The guy comes up and grabs me. My conclusion was, don't sell inshore. Global sea level by 80 centimeters by 2100, over 100 centimeters in New Jersey. There's going to be more beach erosion, more rollback. That's what I showed you, beach moving land. More cost to replenish. We spent $1 billion so far in New Jersey nourishing beaches. That's since 1950. We're going to be spending that every decade in constant dollars. Loss of marshland. Well, the west coast of New Jersey, better known as Delaware Bay, is already going on. We're going to lose 3% roughly of the area of New Jersey. Put a big question about storm intensity. So that was my conclusion. So I'm walking, this guy grabbing from behind. He goes, what kind of conclusion was that? I said, what do you mean? He goes, you know sea level rose at 16 inches in New Jersey in the 20th century. He goes, what about your grandkids? And so, reminded me of, we had published our sea level curve, global sea level curve, past 100 million years that year, and they did a satellite NPR segment on it. So the middle segment was about our curve and its implications. The final segment was from the, I made a statement, said, well, what should we do? Well, the Dutch have lived below sea level for many years, and the last segment was from Dutch people talking about what they're doing. For the first segment, they interviewed people from Vanuatu, 2 scientists from Vanuatu. Vanuatu is here in the South Pacific. It is an island chain formerly known as New Hebrides. One of the 9 deadly sins of Al Gore is he said that there were climate refugees, and the judge ruled that there were no climate refugees. Well, that year, Tega Atoll was evacuated. And so they asked the scientists from Vanuatu, so they have like 0 carbon footprint, right? They said, what would you say to people back home in America?
That's the only thing that I would like to say for all those who are listening, that think of those that are coming behind your children or your future generation.
Thank you.
I have 2 questions. What was Governor Christie's takeaway was my first question, and the other one is ocean acidification. Is that another issue? I know you're a geologist, not a counselor.
Well, mean ocean pH, I'm going to answer that one first. This is a quick one. Is about 8.1, and it is decreasing. And with release of CO2, if you don't believe in the climate effects, you have to believe in the chemistry effects. It's dissolving CO2 in seawater. So we are acidifying seawater. The questions are is how much of an impact that will have, let's say, on corals compared to the temperature rise itself. The El Nino in 1998 resulted in a bleaching of something like 25% of the corals, killing the zooxanthellae, the algae that's in there, and therefore basically killing those organisms off, okay, because they have symbiotic algae. Coming back to the governor, he was very receptive. He ended up keeping us there for an hour and a half on an hour meeting. So sitting across from me was Commissioner Martin of the DEP, the council, and 2 people from an environmental group were to our right. And he came out of that meeting and basically announced that, I wouldn't say the party line, but he announced the Green Party line that looks like humans were very likely affecting climate. But he also was very concerned about RGGI, the Regional Greenhouse Gas Initiative, which New Jersey is a part of. And he looked to me and he goes, well, what do you guys think of RGGI? And I turned to Tony and I started to smile. He looks at me and goes, what are you smiling for? In his best Christie. But he had a smile on his face. I looked at him and I said, Governor, I'm a scientist. That's a political issue. And he looked at Tony and goes, what's the climate effects of RGGI? And I said, well, let me give you my personal opinion, not as a scientist, but I think New Jersey should keep this in because it shows leadership. Just like California led us to tighter standards in pollution control, having the Regional Greenhouse Gas Initiative will push the federal government toward doing it, and ultimately the world, to some kind of system of regulating carbon. And of course, he came out of that meeting and said, we're pulling out of RGGI. So that's, and by the way, he's a superb politician in that sense. His issue, he didn't care about greenhouse gases in terms of climate change. He was saying that cost him nothing at that time. But he wanted to get us out of Reggie because of the business lobby issue effects.
Anyone?
One of the charts you had up showed kind of the temporary leveling prior to the Clean Air Act, and you also mentioned ethics a couple of times, and I'm just wondering what you think about some of the geoengineering proposals, using sulfur dioxide to put back in the air, that kind of thing.
So I belong to the geoengineering mailing list, which fills my box every day. And I don't have time to actually go through and give this a really hard think. Alan Robach's on it too, and he's at Rutgers, and he's an atmospheric scientist, and he's one of the leading proponents against it. I think geoengineering is very hazardous. We're putting sulfate aerosols in is what we just cleaned up. We don't know, we really start mucking around with the planet then. And I think that that's not necessarily a good thing to do. I think there are other means. There are technologies that can begin to be developed to actually remove CO2 from the atmosphere and then bury it underground. But that's not without problems either. Carbon sequestration, which is one of the things I do work on, is also very controversial. I won't want to do it under my backyard. Okay, there are places I think it can be done, but it's a complicated issue.
The Rutgers sea level rise viewer that you mentioned that's online, is that where in the range, like from the least rise to high rise, what does that show? And for example, if somebody's trying to decide whether or not to sell their house, is the data that's shown there, is it reliable enough to make a decision?
I was going to pull it up, but I'm not online. The Rutgers sea level rise viewer uses real topography, mostly from more recent high resolution, but still it only has about a 1 foot of resolution, so you can plug in 1 foot, 2 foot, 3 foot, 4 foot, I think to 5 or 6 feet. So you can get pretty close. So the Atlantic Highlands has to do something, or Highlands right there, because the town is very threatened. And if you can pull it up individual, not quite the individual streets, but you can pull up information. NOAA, this was a NOAA product. There's also Climate Central, has their Surging Seas viewer that does something very similar. They're out of Princeton, so you could play around with that one too.
But you know how you showed the curves, like the least rise and the most rise?
Yes.
Does that viewer show the median rise, or the least, or the highest?
You plug in the foot.
Oh, you do?
You drive.
Oh, I see. Okay.
You drive.
Are you factoring into your predictions anything that has to do with the tundra deteriorating, causing gases, releases, and so forth in the atmosphere?
So why is there so much uncertainty in prediction of climate change? If you take CO2 and double in the atmosphere, temperature should rise by 1 degree Celsius in absence of feedbacks. But there are many feedbacks, and this is where it gets complicated. So there's ice albedo feedback. Okay, that's positive. You melt more of the Arctic, it gets warmer. And as a result, by the way, there's something called polar amplification. So if it goes up a degree at the equator, it's going up 2 degrees at the pole. So what we're seeing in the Arctic isn't a feedback itself. And that feedback is the melting of the permafrost, which is allowing the release of methane stored in ancient bog sediments. The methane is a strong greenhouse gas. Methane oxidizes to carbon dioxide in about 10 years. So if there's one burp, it's turned into, and the thing with methane, even though it's a much stronger greenhouse gas, it's 1,000 times less common than CO2. So we have not figured that in. The main thing we focused in on is the temperature rise, plugging that into the melting of the models for the ice sheets, or what needs to be, melt the ice sheets. So that's what we're focusing in on. The role of methane as a positive feedback is not well understood. So we have not included that.
I had a question as I'm walking over there. I use the FEMA maps a lot with work, and they show the flood limit, the elevation, and it's different from when it gets to the coastal point where it's tidal to where it goes upstream where it's just runoff. So if you added the 1.5 foot, just to the sea level section of the maps? Like how much land mass, like, I don't know, are you including marshlands or?
I can answer that, and I should have made this point. The one slide which showed the impacts. So I mentioned about marshlands. If you raise sea level a foot, okay, the marshes move back 1,000 feet. So in very low gradients like the marshes, okay, there's 1,000 foot of inundation. So if you're 1,000 feet from the bay and you raise sea level a foot, and I'm in the marshes, that's where it will be flooding to. Barrier islands, you could see, even with a 3-foot rise, it's more like 1 to 300, not 1 to 1,000. In terms of living on rivers, and I didn't get into this, for the sake of time, what happens with warmer temperatures is that they drive the hydrologic cycle. And what that means is there's more evaporation. But everything has to balance, so there's more precipitation. So you get more floods and more droughts. So we, in a period of drought now, we'll look at California, but even in New Jersey. But then, if you look at the floods, there's been, what, 3 100-year floods in the Delaware in the past 10 years? So that is another consequence of global warming I did not emphasize. So if you're on rivers, and you need to account for many more 100-year floods in your plan.
Could you estimate, like, on those upstream flood maps, the rise?
Not for the rivers very well. One of the hardest things to do is predict precise precipitation pattern changes, okay? What we can tell you is, in general, here's a good rule of thumb I teach my students, they all remember. The rich get richer and the poor get poorer. Areas which are dry, the Sahel, Darfur, get drier. California, okay? Areas that are wet, Hilo, Hawaii, Indonesia, okay, get wetter. And areas that are in between don't change much on mean annual, but it gets flashier, which is this more droughts, more floods.
Early on in the lecture, you were talking about, I think the initials were IGA maybe?
IPCC. Wasn't
It
it?
was something about having to do with the
Oh,
glaciers.
GIA, Glacial
GIA.
Isostatic Adjustment.
And I know you said you were going to discuss what that was, and maybe I missed the
That's the
discussion.
nutritionally challenged kid on the other side of the seesaw. That's the seesaw effect. The heavyset person gets off the seesaw, you're way up in the air. It bounces up, you sink down. That is GIA for our region. It's more complicated, and the removal of that big ice sheet, we call it the Laurentide ice sheet, affects a lot of area, and so there's, the sea level rise is therefore global. So we're seeing a extra rise in sea level. England and Greenland are actually seeing less of a rise in sea level.
Could you please discuss the role of plants in reducing carbon dioxide and other ways of possibly mitigating the amount of carbon dioxide? And also, is anything that little individuals like us can do, does it have any impact, or is it totally useless?
Those are very good questions. Well, plants, our release of 10 gigatons per year is not all from fossil fuel. It's basically deforestation too. So I believe that that's on the order of roughly 20% of the effect. So years of living dangerously, I've only seen the debut episode, but showing you the massive deforestation, not so much in Brazil as it is in Borneo and Indonesia. And so that is contributing to the rise in CO2. Obviously, planting more, making us greener helps a bit. It's not going to be the total solution to the problem, but the solution to the problem, there is no one solution. So Sokolow at Princeton has what he calls wedges. Each of those wedges contribute to a reduction. The wedges include reduction of coal, movement toward nuclear, burning of carbon dioxide in the ground, capturing it from the power plants and burning it, moving to an electrical-based auto system, just in general greening. And you have to do them all. So the thing about conservation is, if you conserve, are you personally really contributing? Well, it's kind of like the, what's the term, the means, the ethical question of the tragedy of the commons. The tragedy of the commons. So I never wanted to buy, grew up in a military family. My dad didn't want me to buy a Japanese car. And I said, well, I hope everyone else buys an American, Dad, but I'm going to buy a Japanese car because they're the most efficient right now, get the best gas mileage. And so that's a decision you make, you know. Did my decision affect Detroit? No, but if my whole generation has had that same feeling, guess what? Detroit's feeling the pinch, and that's what happened. So if you save a little, and get your neighbor to save a little, it was kind of what we told back, I told about Governor Christie. It's the leadership. New Jersey could be a leader in this, as opposed to now we're going down the other path with our government.
There's statistics about the CO2 required for creating the meat-based industry. I'm a vegetarian, and if everybody was a vegetarian, how much less CO2 would there be in the world? And that was one thing. The other thing was, with the models that you were showing, was there anything taken into account for unexpected events like another Krakatoa?
Okay, I can't answer. My depth of knowledge on production of meat, particularly beef, is limited to my listening to All Things Considered. Which you probably heard the same episode I did. And it's most intense. And actually, by the way, it gave me some thought about, yeah, maybe it isn't so bad staying away from beef. And of course, the prices nowadays, the market's going up. In terms of other events, if there's a large volcanic explosion, well, we had one. We had that experiment, 1993, Pinatubo. And we had half a degree of global cooling. And within 2 years, it's back. Well, actually, within a real year, it's back because it settles out. So
It wasn't on the scale of Krakatoa, though.
Or Toba, which is even bigger. Toba was 1815, and we can thank Toba for Frankenstein. Mary Shelley was living in London. That was the year without a summer. She had to leave London. The dreary year without a summer, wrote a dreary novel called Frankenstein. So Toba is the largest that we know, going back about 50,000 years. So yes, it's possible that Yellowstone would explode. Yes, it's possible that we could get hit by a 10-kilometer across meteorite, like the one that killed the dinosaurs. One of my other favorite series of stories, I do lectures on that. But I wouldn't worry about those particular things.
I'm interested in the fact that you recommend beach replenishment, because I remember years ago listening to a geologist saying about beach replenishment that the ocean will always win. And given that, would it not be better if we just pushed the development back and say, this is what's going to happen? Because every time we replenish a beach, a storm will come and get rid of it. So it's very expensive, and are we getting anywhere, really?
So beach nourishment is quite ephemeral. So the average is about 5 years and it has to be redone again. And faster rising sea level, that will be shorter. In a place like Ocean City, I think New Jersey is nourished a couple times, and by the following year, it had lost its beach. It's just in a lucky place. New Jersey's economy, though, basically we have $1 trillion, or at least about $500 billion maybe, in beach real estate, shoreline real estate. But our economy has a huge, I can't come up with the numbers, I should have reviewed them when I teach this, but the amount of our economy that's tied to the shore is large. So the investment itself is probably worth it. In terms of encouraging future development, this is the ethical and political issue that we should try to limit further development. We kind of did that in the Pinelands, although I grew up in the Pines, and I can say, well, it hasn't been that successful, okay? But we have preserved a lot. So it is possible to try and preserve it. areas in North Carolina, it doesn't make sense to nourish a beach where there's 20 houses along a mile-long stretch. But when you have a area like Long Branch, which is very heavily developed, you're not going to let it fall. We're not going to let New York City fall into the ocean. Okay? We're going to rebuild the beaches on Long Island because they're an economic engine, and the same in New Jersey. So again, some people may not be happy with that from an ethical perspective. Should we step back? That's an economic decision.
Again, another ethical question. Do people who predict the future factor in population growth and the size of the population? If the population grows, we're going to burn more fossil fuel, we're going to cut down more trees, whatever. Does that ever get discussed? Population is part of the problem.
Well, I mean, certainly population growth, I think, is our greatest threat, okay, because it all goes together. The models that the IPCC use start out with economic forecast of population growth, etc. And that's where the scenarios for emission scenarios are developed. So we are following what used to be called, it's like, it gives them all kinds of goofy names now, but it used to be called business as usual. And that we're going to continue to grow exponentially, and as people in China want dishwashers, and then people in Bangladesh want dishwashers, and population grows also, that's basically the high-end scenario, okay? We're tracking on that high-end scenario and have been for a long time. So again, it has taken population growth into account. From an ethical perspective, so, all right, Pliocene is a warm interval. I work on that as one my intervals. It's 3 million years ago. So our hominid ancestors were in Africa. Climates were much warmer than present, about 2 degrees Celsius warmer. Sea levels stood 20 meters higher than present, 60 feet. It was a nice time for the planet. Okay, a warmer planet's not a bad thing. Okay, what is a bad thing is that, first of all, our economic systems are founded on the current climate. Our breadbaskets and production intervals depend on predictions of the current climate staying the same. Sure, we can move some of our food production out of California to warmer areas in the future, but at the same time, we'll be trying to feed 9 billion people by the year 2050. Okay, when then projections suggest we should start leveling off. And that is going to be very difficult to do in the face of climate change. So I think that answers the question right there, at least I hope.
But do people take it seriously that population's part of the problem that needs to be addressed?
Well, the people in the United States, well, certainly in Europe, they've taken it seriously. They're encouraging people to have more children now. Okay. Yeah. Only France? I didn't read the full article in the New York Times on that, yeah. But I mean, again, here's the ethical question. We're at the great regions of population growth, some of the poorest areas in the world. So again, yes, I think the projections to a certain extent assume that we will affect those areas that are growing so fast, will kind of fall into the same category as ours. But
I don't know if this is geological or not, but there have been lots of proposals of what to do for the beaches in New Jersey. And one I have heard is to build barrier islands for the barrier islands, like artificial islands. Would that have any ameliorating effect on storms and beach erosion, et cetera?
my undergraduate degree is in geology. My PhD is actually in oceanography. And I was sitting in the Department of Marine and Coastal Sciences at Rutgers about 6 months ago, and Bob Chant walked in from a meeting on this. And he's a physical oceanographer that actually models the flow in like Barnegat Bay and other places like that, bodies of water behind estuaries, New York Harbor. This is what his shtick is. And he goes, this is the most ridiculous thing I've ever seen. Because it affects, think of what the effects would be. There's no waves coming into the current barriers. And what about the flow into the estuaries and out of the estuaries? There would be some severe effects of that. So that falls into the geoengineering category of not good.
Did you say insure your house? Is that what one of your recommendations is?
I absolutely, yes.
Can you insure your house?
So I sold my house.
So should we do what you did?
Okay,
Do what
so
you
I
said.
actually put, the people that bought my house were neighbors from up the street, and they looked me up and they go, wait a minute, shouldn't I sell my short house? And so I put a post on Facebook and basically said, look, we're selling the house. And I go, we don't use it enough, so it's actually our personal decision. Why are we maintaining? If we can maintain it, why would you? But it also became an issue. It's a hell of a lot of work, and a hell of a lot of work fighting back from Sandy. It's a hell of a lot of work fighting back from all these storms. And so we didn't want to do that battle. And so other people who are living at the shore and find it on a day-to-day basis worthwhile to be able to go to the beach and enjoy the area, fight back. But another Sandy could happen tomorrow. We all know that. I can't tell you, are there going to be more Sandys? Don't know. We really don't know.
I'll get to you in 1 second. I got another question. The Navesink River is right out here, and it confluences with the Shrewsbury River down by like Rumson and Seabright. And I canoe and kayak through there a lot, and there's an island there we call Starvation Island, and it goes back, people might remember it, like my brother went camping on there, the Cub Scouts would go out there camping and stuff like that. And there was a recent article in one of the local media things about someone wanting to buy 2 of these other islands out there in the confluence there that are zoned, you know, residential in Rumson, and they want to build some houses out there somehow or another. And it got me thinking about it, and you know, I went back through all these historical aerials just to look to see, because if you go into Google right now, you look at that island, the one I'm talking about, the one that they're buying is 2 other things, but it's gone, it's not there anymore. And I'm like, I remember looking at USGS maps and seeing like remnants of a house on there, so I went back to all these historic areas, and sure enough, there was like 8 bungalows on this thing, like back, in the 50s and 60s, and like, you go through and all of a sudden they were gone in the aerials, and now it's the island is gone. It's amazing.
I have a picture in my hallway by an artist from Long Beach Island of Tucker's Island, which had a wonderful hotel on it down by Little Egg Inlet, okay? And of course, the Shifting Sands, Beach Haven Inlet's not open anymore. The Shifting Sands, that island disappeared. Then it reappeared. So, somebody, I'm sure, would try to want to build on it, but then, it's things like that. So we'll talk about what we can do. This is actually where government can be good by setting strong regulations and zoning. And it has to come from above the local level, as you well know. Some of the local level will protect in certain areas, and others, like said, deal, that's, it's to their own detriment. So, yeah, I hope that whoever the zoning board is that has, whether it be Rumson or whoever has control over that, make sure that that doesn't happen.
Yeah.
Are algae blooms and fish kills related to sea level rise?
They're relating to global warming. The fish population changes around here have been pretty strong, and it's mostly due to the warmer temperature. I flew over the Jersey Shore and all of a sudden looked down and said, oh my God, there's a huge bloom out there, okay? And we weren't supposed to we don't get the typical red tides with the same Dinocyst, but this was another species, okay? Well, we're getting more and more blooms. So as the temperature rises, you will also have more fish kills because of the warmer temperatures. In the summer, the offshore becomes stratified, and then the bottom goes without oxygen or anoxia, and that's what causes fish kills. And that will be more frequent in New Jersey with warmer temperatures. Sea level is minimal effect in that, except just inundating marshlands.
All right, we only have time. It's noon now, so we're going to wrap this up. So maybe just 1 or 2 more questions.
Hi, Dr. Miller. I purchased a home in Brick a year before Sandy, on the bay, on the marsh, across from the Manalocan Bridge where the ocean breached. Across the street is the lagoon. I was like an island. I received significant damage, as you can imagine. FEMA came out initially and put us in the high velocity zone, and I believe I was at B10. They retracted, put us down to AE7. My neighbors behind me that have more protection kept with the V zone and put concrete columns to lift their homes, and they went quite high. I told my engineer I'd like to use the concrete columns and go up to V or 13 feet, possibly 14, because I'm petrified, I lost everything. Being that I'm on the marsh and the location of my property, what would you recommend?
Well, my house, you saw, was on pilings, okay? And being that you're on the marsh, going as high as you can. So my next door neighbor was only gonna raise 4 feet. I said, no, you gotta go at least 6 feet up, and not more. Of course, then at that point, this becomes an engineering decision, because whether or not, if you go a little more than 6 feet, you can pull your car underneath, right? So, but you also then become an eyesore to everyone around you. There's most positives of going high. Okay, so the neighbor behind me is a few feet higher than me. If he had been in front of me, I would have lost my bay view. So then it becomes an arms race of who can raise up until the maximum, right? When there are maximum. The other problem is there's a lot of people here who, you know, if you're over 60, at some point having to go up that 10 feet of stairs gets more and more difficult. So my mother-in-law lived in Waretown, and we couldn't move her into our house because she couldn't make it up all those stairs. So that's the downside as you get older. But I would go as high as you can.
So if I'm at 7.6, I believe is the BFE.
Right.
You don't think I'm out of my mind if I go up to 14?
No. Actually, that's what mine is, actually. The so-called basement is the 7-foot flood mark. So I'll give you the numbers. Maybe we'll do one more question. I'll just give you the numbers. So my house is at 7 feet. I went to put in a new heater about 5 years ago. And I said, oh, you got to go up at least another foot. It's not going to fit. I have to hang it sideways. I said, what? And he goes, yeah, the DEP came out with new guidelines, and most towns follow those. So I was now at 8 feet. Now with the new ABFEs, the Basal Flood Elevation Advisory ones, FEMA's putting on 2 more feet, okay? And New Jersey's keeping their 1 foot. By the way, that 1 foot came in under Mark Margariello as the DEP commissioner under the Corzine administration. It was due to sea level rise. You're not allowed to call it that now. It's just called a safety factor. DEP did not use the word climate change. We're no different than Wisconsin, guys. Okay. Or Florida, or North Carolina, where they have the King Canute syndrome. Sea level cannot rise! My namesake. So let me just answer. So I'll finish it off with these numbers. You need to go at least, I would say, another 1.5 feet minimum above that. But you're local. You're in a marsh, so you're going to be sinking even more. So I would just go as high as you can.
And then sell it once it's up there.
No, we have time for this last question.
Okay. We live in Ocean County. By its name is all scary. But our big problem is Barnegat Bay. And we understand that it's not being washed out by the floods, and the creatures that are in there are scary too. What do you think about that, and what's the solution?
So you guys should get Mike Kennish. Put him on your list. Mike lives in Tom's River. He's great on outreach. And he is the expert on Barnegat Bay. So yes, sea nettles, jellyfish are up dramatically, temperature effect. The thing that is killing Barnegat Bay, to a certain extent, is runoff from fertilizers. And so now DEP has put certain constraints that if you're a certain distance from the watershed, you can't use fertilizer. But it's the guy up, Cedar Creek, that's using fertilizer, it's washing in. It's got to be more of a regional solution. But have Mike come out and he'll tell you about all the things that are going on. Water quality was excellent last year. We didn't have the nettle problem, but it's going to be a problem going forward.
All right, well, big round of applause. Thank you so much.
you.